Hello everyone, welcome to the No Mr. Science channel. And before we start the solution step by step, please like the video and subscribe to the channel. Now, let's go for our solution step by step. Determine the internal normal force, shear force, and moment at point C in the double overhang beam. So first, we're gonna split our our load in two triangular ones. So from here, I'm gonna call P2, and here I'm gonna call P1. So our equivalent load P1 is equal the area of this triangle that I have 3 times 4.5 divided by 2. So our equivalent load P1 is equal to 6.75 kilonewtons. Since the triangle, the point is 1/3 from our maximum height. So our P1 is right here. So here we have P1. P2 is the same approach. So our P2 is equal 3 times 1.5 divided by 2. Our P2 is equal to 2.25 kilonewtons, and it's apply 1/3. So here to where P2 is, I have 0.5 meters and 1 meter from the overhang. Now we can find with our equations of equilibrium, Fx is equal to 0, the sum of Fy is equal to 0, and the sum of moments is equal to 0, our reactions. Since we just intersect at point C, we have to think what's the best way to do our cut. So further, I'm gonna do the cut here and stay with my left side. So I just gonna find our A reactions. So here I'm gonna start with the sum of forces in X is equal to 0. I know my AX is equal to 0 from the reactions. Here I just have BY because it's a roller, and here is the pin connection AY and AX. So my AX is equal to 0, and in order to find my AY, I'm gonna do the sum of moments about point P is equal to 0. So here I have AY times 3, that's my distance, minus P1 times 1.5 plus P2 times 0.5, that's our distance, is equal to 0. So here I have 3AY minus 6.75 times 1.5 plus 2.25 times 0.5 is equal to 0. Here I have 3AY is equal to 9. Now we discover that our AY is equal to 3 kilonewtons. Now we discover our external reactions for point A. We can find our internal forces. So before we apply our internal forces, here we have a point of the height that we don't know. But from the previous exercise, we have two triangles. We have this one here that is 4.5 with a height of 3, and then we have this internal one. Change the color, put yellow. This one here. We have this one here that we don't know. I'm gonna call omega c, and then we know this distance from here to here, that's 3. Now we're gonna use similar triangles, so 3 over 4.5 is equal our height omega c over 3. So our omega c is equal to 2 kilonewtons per meter. So now that we discovered this, we can find the equivalent load of this second triangle. So we're going to call P3 is equal to height 2 times base 3 divided by 2. Our P3 is equal to 3 kilonewtons. So here we have a external reaction here, 3 kilonewtons. Here we're gonna have 3, so the distance from here to our P is gonna be 1. So here 3 kilonewtons as well, 1.0 from point C. Now we have our normal C, our shear C pointing down, and then our moment that's going counterclockwise, moment C. Now we're going to use our equations of equilibrium. Sum of forces in X is equal to 0. The sum of forces in Y is equal to 0. And the sum of moments is equal to 0. Starting with the sum of forces in X directions is equal to 0. So we know that our normal C is equal to 0. So first internal force we found. Now let's go for our shear force. The sum of forces in Y is equal to 0. We have AY minus P3 minus the shear at C is equal to 0. 3 minus 3 is equal to shear at C. So the shear force at point C is equal to 0. So now we found our second internal force. Now, sum of moments about point C is equal to 0. We have MC that's going counterclockwise plus 3 times 1, that's our P3, minus 3 times 1.5, that's our AY. It's equal to 0. So here we have MC is equal 4.5 minus 3. Our MC is equal to 1.5 kilonewtons times meter. So we finalize our exercise finding our internal forces. Thanks for watching to the end. Don't forget to like the video and subscribe to the channel, and see you in the next exercise. Thank you.